Hello, viewers. In today's session, we are going to discuss an important result from pair of straight lines, right? And the result is related to a formula which is used to find out the product of perpendiculars, right? So let us start. Now, see, we know that a pair of straight lines passing through the origin is given by this second degree homogeneous equation, that is ax square plus 2hxy plus by square is equal to 0, right? So this equation represents a pair of straight lines passing through the origin, and the individual lines has equations, that is y is equal to m1x and y is equal to m2x, right? So these are the two equations of the lines which passes through the origin having the slopes m1 and m2. So now consider the rectangular coordinate axis, and let us represent these two lines, y is equal to m1x and y is equal to m2x, right? Suppose this is our line, y is equal to m1x, which passes through the origin, and let us consider the second line like this. Suppose this is our line, y is equal to m2x, right? And the combined equations of these two lines is given by this second degree homogeneous equation, right? Now suppose consider a point, say P, whose coordinates are say x1 comma y1, right? So what we have to do in this lecture is to find the product of perpendiculars which are drawn from this point P, x1 y1 to these two lines. So now let us draw the perpendicular from this point P to this line, and suppose the perpendicular is like this, right? So let us take this point as M, and let us draw a perpendicular from this point P to this line, that is y is equal to m1x, and let us consider this point, that is the foot of the perpendicular, as n, right? So what we have to do here, we have to find out the length of the product of perpendiculars which are drawn from this point P to these two lines, right? So here the length of the perpendicular from this point P, x1 y1 to the first line, that is y is equal to m1x, is given by Pn, right? And the length of the perpendicular from this point P to the second line, y is equal to m2x, is Pm, right? So we have to find the product of the length of the perpendicular drawn from this point P to these two lines. So we have to find Pn times Pm, right? So here we are not going to derive the result for the product of perpendiculars, rather we'll use the direct result. So the direct formula for finding out the product of the length of these two perpendiculars is given by ax1 square plus 2hx1y1, and here we have b y1 square, and we'll divide the numerator by the square root of a minus b square, and here we have 4h square, right? So we'll consider an example how we can find out the length of the perpendicular to these two lines, the product of the perpendiculars to these two lines, by using this direct result. So let us consider the example. So let us consider this problem in which we have to find the length of the product of the perpendiculars drawn from the point 2 comma 3 to the pair of lines x square minus 7xy plus 6y square is equal to 0, right? So here we are given this point 2 comma 3, which is our point p x1 y1. So we have x1 is equal to 2, y1 is equal to 3, right? And here the pair of lines, these two lines are given by this equation, that is the combined equation of these two lines is given by this second degree homogeneous equation. So comparing this equation with this one, the value of a is 1 here, that is a is 1. The value of 2h is given by minus 7, and h is minus 7 over 2, and the value of b is given by 6. So now substituting these values in this result, we have Pn times Pm is given by ax1 square. A is 1, we have 2 square, then we have here 2h x1 y1, 2h is minus 7, so we have here minus 7 times x1 y1. X1 is 2, y1 is 3, then we have b y1 square, b is 6, and this is 3 square, right? And in the denominator we have a minus b square. A is 1, b is 6, so we have 1 minus 6 square, then we have 4 times h square. H is minus 7 over 2 square. So now we have 1 times 2 square is 4. This is 3 times 2, 6. 6 times 7 is 42. So we have minus 42. And then we have 9 times 6 is 54. And here we have minus 5 square. This is 4 times h square, that is 49 over 4. 4 and 4 get cancelled, so here we have 54 plus 4 is 58, minus 42 divided by square root of minus 5 square is 45, and here we have 49. So 58 minus 42 is 16, and here we have square root of 74. So viewers, the length of the product of the perpendiculars drawn from this point 2 comma 3 to the pair of lines x square minus 7xy plus 6y square is equal to 0 is given by 16 over square root of 74 units.